everyone! This series of videos will take you through page 6 in the packet, which is an exploration of something called rational exponents. Rational exponents are a new sort of exponent that, in theory, will help us better understand all the different ways that exponents can look, especially when we start to evolve our understanding of exponents beyond just a thing that tells us how many times we multiply. By definition, that's what we've always learned about exponents in the past. Exponents are just things that tell us, almost as kind of like a counter, how many times we're multiplying by something. So for example, when you have something like 2 to the power of 4, that's like saying you're multiplying 2 times 2 times 2 times 2 4 times. So the 4 is kind of like a counter that tells you how many of those bases that we have. And we know that generally speaking, that's how exponents were always presented to us. In the previous lesson though, we looked at what happens when exponents are negative, which is where intuitively you're not really thinking about 4 as a counter anymore, because 2 to the negative 4 doesn't mean you have negative 4 amount of 2's. And it's harder to conceptualize a negative exponent as a number of times you're doing something, because that's not really how negative numbers work in real life. So we have to evolve our understanding of exponents so that we're not too limited by saying, oh, it's just the number of times we do something. Negative exponents and now what we call rational exponents will help us look at exponents a bit differently. The first thing that you're going to do in this lesson is actually a Desmos activity. So before you actually do anything on page 6 in the new packet, make sure that you have the link to student.desmos.com open. You can find a direct link in the learning plan, or you can simply copy the link that you see on the screen here. You can go to student.desmos.com and enter this 6-digit code. Or you can go to the link in the learning plan that already has the code embedded in it, and you can just click on the link in the learning plan to get you there directly. In any case, it's going to take you to a Desmos activity that involves sorting a bunch of little cards. And I have printed versions of the cards here just to give you a preview, so that when you get to the Desmos screen, you'll have an idea of what to do. You're going to be creating what we call triplets out of these cards. A triplet will contain one of each of these types. And you can see my cards are color-coded, which in the Desmos won't really be a luxury that we can enjoy, but I'll still give you a preview so you can understand what you're going for. One of the types of cards you're going to deal with is an integer. An integer is something just like a regular number. An integer by definition is what many of us call a whole number. So this card, for example, is 128. That's an integer card. A radical card, the blue one here, is something that looks like it has a root. Now we're not going to call it a square root, because by definition a square root is something that doesn't have a little number next to it. We're going to call these radicals, and you'll understand why once you do a little bit more work in this lesson. The third and final type of card is called a rational exponent. Rational is another word for fractional. So when you see the fraction exponent cards, you'll recognize them. The fractions are clear, like in this one, 7 over 2 is a fraction. And you can tell that it's a superscript. You can tell that it's a smaller size font, kind of lifted up in the air a little bit, endemic of an exponent that we normally see. So that'll give you a hint when you see a rational exponent card about exactly what you're looking for. So you're going to create these triplets. How you create a triplet is entirely up to you, but I'll give you a few hints to help make the process easier. First, I would suggest focusing on the integer and the rational exponent cards. The first thing I would personally do, if I had access to such a thing, and I hope you'll do, or that you will, is to grab a calculator. Any calculator will do. If you have a graphing calculator, that's great. If you just have a standard calculator like a scientific, that's fine too. Even your phone calculator will work. And in your phone calculator, or any calculator that you're going to use, I just suggest you make sure it has an exponent button. For example, on this calculator, the exponent button is right over here, kind of kitty corner to the 7. On a traditional graphing calculator, the exponent button is right above the divide sign. On a phone calculator, you might need to rotate it sideways to get full access to all of your buttons, but usually there's an exponent button in that sideways menu. And I know the glare on mine's pretty bad, but hopefully you can kind of see where my thumb is pointing there. That's where the exponent button on my phone calculator is. But again, notice I'm rotated sideways so that you can see more of the options. Now, the reason I'm saying to use a calculator is because if you don't really know what negative 27 to the 1/3 is, or if you don't really know what 25 to the power of 5 over 2 is, I wouldn't expect you to have any other intuition for these cards other than to simply type them in. So when you get to Desmos, find a rational exponent card of some sort. Any sort of rational exponent card you can. They're not going to be colored gold like mine are here, but you'll see them labeled. It'll say rational exponent when you're looking at a card in Desmos of that type. If you type that expression into your calculator, so 4 to the power of parentheses 7 over 2, I always recommend using parentheses around fractions in calculators. That's just general practice for any type of calculator, not just this type here. It will give you an answer. And that answer will be an integer. Find the integer card that matches and immediately pair those up. So I can tell, for example, that these two cards, 4 to the power of 7 over 2 and 128, definitely go together. In Desmos, you'll simply drag and drop these two cards together, so that way you can see them as a partnership. Now, you can certainly just go through each of the rational exponent cards, quickly type them into a calculator, and match them to their appropriate match pretty quickly. You can kind of do that, I would say, first if you wanted to. For example, you could do another one, let's say 1,000 to the power of parentheses 1 over 3. That would be 10. So I can find the integer card that has a 10, and I'll, again, just partner those up. So notice you could just do all of the pairs at first and then worry about the third type of card at the end, and that might be a good idea. Or you can try to build the triplets right off the bat. The triplet aspect comes from the idea that the third type of card, these radical cards, have really nothing to do with anything mathematical. I don't even expect you to use your calculator. But I would expect you to use a little bit of common sense. Do you see how something about this card, even though I don't really know the significance of the 4, the 2, and the 7, just seems like it makes sense that it kind of goes with another card that has a 4 and a 2 and a 7? I still don't know what that relationship is. I don't know why they go together, but my instinct is telling me they go together. Because if I look at all the other blue cards, and again, these are just all the other options that I could be matching, none of them appear to have all of those same values, 4s and 7s and 2s. I mean, I don't see anything that has anything like it. So if you can use common sense to help you dictate the third card in your triplet, I would say don't overthink it and just use a bit of common sense. The gold and the blue, in this case the radical and the rational exponent cards, really do go together with a bit of common sense. Don't overthink that pairing, and I think you'll all of a sudden find that's the easiest pairing that you can make. So the calculator can help you link the rational exponent cards with the integer cards. Common sense can help you link the rational exponent cards to the radical cards, so in theory you should be able to match all three of them together. Now the downside to the Desmos activity is that it doesn't tell you if your matches are correct or not. So there's an answer key linked in the learning plan, and I recommend that you have the answer key open in a separate tab so that you can go back and forth between the Desmos screen and the answer key screen, and you can check your answers as you go. If a match is wrong, you'll know, and then hopefully you can use a little bit of logic to help you figure things out. Once you finish sorting all the cards in Desmos, then you'll come back to question number 1 here and make some observations. So question number 1 is meant to be done after you do the Desmos. If you can, Pick one little triplet of cards, and you can use this one if you want to simply take a screenshot of this video so that you can see a triplet right here. And it's going to ask you to list the three aspects. So I would write, if this was the one I was picking, the contents of the radical card in the first box. I'd write the contents of the rational exponent card in the second box. And I'd write the integer card in the third box. Order is whatever, doesn't matter. It says in letter B, explain how you knew they went together. So you can explain your process. Well, I did the rational exponent in the calculator. That told me the integer. And then I noticed that this card had a 4, a 2, and a 7 with the radical card that also had a 4, a 2, and a 7. So I figured out that those went together. You can put that in whatever words or diagrams or arrows or whatever expressions you want to. And then in letter C, it's going to ask you, big picture, what are all of the patterns did you notice? Did you notice something that transcended just one set of cards? Did you notice something that all of the triplets that you created had in common? Did you notice something that seems to be universal? Because it's that observation, any observation that you can make that is universal in nature, that's going to help you with the rest of page 6. So, first task before you start the next video is to do the Desmos. Second task before you start the next video is to complete number 1. Once you do that, the next video is going to walk you through the rest of the questions on this page, but I recommend that you have done the Desmos first so that those patterns and observations are clear. It's easier to do the rest of these problems when you have the observations in mind.